We now move to another idea called least common multiple. Multiple and greatest common factor get many times mixed up, and where we use this concept again is through fractions, simplifying fractions, adding and subtracting fractions. We use this idea there, and so the least common multiple of two numbers or more numbers is the smallest non-zero whole number that is a multiple of each of these numbers. And multiples, again, you can see it's like you build them up: 24, 48, 72, and then so to find them, use what we say is the intersection. So the least common multiple, 24 and 36, you keep building up, and then you find the intersection, and then you see that 72 is the least, what do they have in common here? 72 is the least common multiple of 24 and 36. We can also use a prime factorization method to find them. We'll look at that right now. Very similar to the greatest common factor. Least common multiple many times is what's called the greatest common denominator in fractions, but we'll look at that when we get to fractions later on. The build-up method is a third way that I'll explain. So let's go back. We've done the greatest common factor of 42 and 24. We did that back here, and we got the answer of 6, right? So smaller factors are the building blocks of numbers. The multiples are the numbers that come from numbers, right? 24, 48, 72. So you will see the intersection method here, that 168 is the first whole number, the first multiple in common for 24 and 42. So that's your answer. At least common multiple is 168. Another way we would do this would be through prime factorization. So notice we have that. And what happens is you look to see, in this case, since we're looking for the bigger value, you take each factor that they have. They have a 2, a 3, and a 7. And then you take the largest exponent. So for 2, there's 2 to the power of 3, 2 to the power of 1, so you keep the 3. 3 in the power of 1, 3 to the power of 1, keep 3 to the power of 1. This has a 7. Keep the 7 to the power of 1. And when you multiply that, you get 168. Now another method is what's called the build-up method. And so once you have the prime factorization like this, what you do is you just combine them to kind of build up. You look at your 2's and say, okay, very similar to which one's the greatest one here, and just say, okay, I need to add 2 more to this one here to make it 2 to the power of 3. And so there's your 2 to the power of 3. I want them to have the same factors, and that's how I'll build it up. And so then this has the same already, so I keep the 3. And then this needs a 7, so I put the 7, and you get 168. They're very similar. It's just another way to think about it. The build up and the prime factorization is kind of how you build from it, but really you're looking at the prime factorizations to help you build what the least common multiple is. And then to end this here, there's some cool number theory things that you may want to try on your own. I've done one here. You can quickly get down that the GCF of times the LCM of the same two numbers is A times B. It's kind of just a cool theory. And then this is kind of cool again for number theory. People thought about it. This idea that there is an infinite number of primes, right? Here's a proof you can read. We're not going to expect you to know this or memorize this, but just some cool number theory about prime numbers, that they go on forever.